Hi, this video is meant to help introduce the kinds of transformations that can be applied to a sine curve. Initially, we're going to show a few graphical examples of the sine curve being transformed, and then we're going to look at the math and its connection to the graph and how changing the math will affect the sine curve graphically. So to get started here, we have three controls on the side and a graph. So I'm going to move each of the graphs slowly, and as I do each one, I want you to pay attention to how the graph changes and make note of what it's doing to the graph. And each of these three sliders is going to do something the other ones don't do. They're going to have a different effect on the graph. So let's get started. We'll start with the first slider. Its current value is 1, and as I increase it, let's see what happens. So pay attention to the graph. So now it's at value 3, 4, 5. I'll stop at 5 here. And notice that, you probably noticed that the height is changing. And this is called the amplitude. And the amplitude is half the distance between the maximum and minimum shown. So here, also notice when the slider is at 5, it's reached the point 5 on the graph. So I'm going to drag this back down to 1. And also notice here it's reached the graph at 1. Let's try the next slider. I'm going to start moving it to a larger number. Okay, so what's happening? Instead of increasing the amplitude, it's sort of shrinking, or these curves that go back and forth in the sine curve are getting closer together. And now, as it grows smaller and smaller, it stretches further apart. Alright, that's different from stretching vertically. It's sort of stretching horizontally. Now finally, the last one starts at the value of 1, and I'm going to start increasing it. Let's try that again. It starts at 1. As I start increasing it, what's happening? You might say it's shifting. So the curve is shifting left as I increase this value. If I start dragging back and make the value smaller, the curve is shifting the other direction. So this time it's not going larger, kind of stretching vertically or stretching horizontally, but it's just sort of shifting the curve left and right. Okay, now let's connect this with the math. Try to learn about how the algebraic expression relates to the graph. Let's start out with just a simple plot here. Y equals sine x. What does that look like? We can create a graph, put it on here, and this looks similar to what we were just looking at. Okay. So let me move the math over here a little bit and add a number here. I'm going to write a 2, so it's 2 times sine of x. This looks familiar to something we were just looking at. Remember the first slider, whatever the value was, it was changing where the height, what value the height would rise to. So just to try something out, we'll cross out the 2 and write a 3. Okay, and so now it looks like whatever this value is, it determines how high the graph goes, sort of the amplitude. So instead of writing in numbers, let's put a variable in, and we'll assign a value, a equals 1. We'll create a slider again, and just do the same thing we did before, and it looks familiar. So as we change the value of a in front of the equation, we can see what it's doing on the graph. Alright, let's change the equation again. I'm not really going to go into why I'm changing it the way I am at the moment. So we'll just look at the effects of it and look at the form of the equation and what it does in the graph. So instead of b, let's write a 2 in here. Okay, so the graph, let's go back to a 1 for a minute. Cross out the 2 here and write a 1. So what happened going just between the 2 and the 1? The graph is shrinking. And we saw that with one of the sliders as well in the opening of this video. So let's do the same thing again. We'll replace that with a value, a variable, or parameter. We'll assign it initially a value of 1. And then let's just drag this. So as the value of b goes up and down, we see something we saw in the beginning again, that the graph stretches horizontally. Okay, so you can see we have this general form of an equation forming here. Y equals a, some parameter, variable, times the sine of b, another parameter, times x. Let's add to this again. We'll scribble out the parenthesis here and write plus c. Save this new math. And let's assign c a value. Okay, c equals 1. I'm just going to start stretching this, and again, we've seen this before. Now we're shifting the sine curve left and right. This is called the phase. Okay? And last change, this wasn't shown in the beginning. We only had 3 sliders, but I'm going to add one more because this is an important part of the generalizing this formula. Let's create d. We'll set it initially equal to 0. And I think you might have, if you saw what happened there, you can probably guess what's going on. But now let's see what happens as we start changing d slowly. Alright, this is yet another transformation of the sine curve. So if you have an equation like the one above, y equals a sine of b times x plus c, quantity, plus d. If you change the value of d, increasing it and decreasing it, you translate the function up or down. Okay, and that concludes this first introduction to this topic.